kind of the basics of milling. We're going to take a part and some stock, cut apart, and create some code. So we'll start with our part. So I'm going to do a file, open, and I'll open up our part. So here's our part. And let's say that it's cut out of an extruded piece of aluminum. And then let's say that it's easy enough to create your own stock, but let's say that our designers actually had a model of the extruded cross-section of this part. So let's merge in our stock, and that's what we'll use to verify our cuts. So I'm going to go ahead and merge our stock, and then we can start interrogating the part. So let's look at the stock, the top of this. So right-click element data, and I can see that there's 25 thousandths of stock on the top that we have to face off. And for creating our toolpath, we don't need the stock. We're cutting the part. We'll use the stock and verify to show the cut. So I'm going to hide the stock, but I'll right-click and I'll hide that layer step. And then I can now look at the top of this part, right-click in element data, and then I can see that that's right at 0. So I've got 25 thousandths material to face off the top of this. So before we do any cutting, though, let's plan our cutting. And we can look at our planner. And we can see here we're going to face the stock off with a 4-inch diameter face mill. We're going to finish the pocket and the outer profile with a 1/2-inch end mill. And then we'll spot and countersink all the holes with a 1/2-inch diameter spot drill. Then we'll drill the through holes, and that's the corner holes, the 4 corner holes, with a 312 drill. Then we'll tap drill the 1032 holes with a 159 drill. And then we'll come in with a tap. We'll tap it, and then we'll be done. And then we can look at our job info. We can fill in all the stuff we need here, who's doing it, who it's for, etc. Then the machine, I'm using our example 3-axis milling center that ships with SmartCAM on our work setup. We don't have our stock layer defined. I'm not sure what layer that is. So it looks like layer 999. That's where our stock is located, on layer 999. So I'll pick that. We can preview it. So I'll click the preview, and I can see the stock show up over the top of our part. So we're all planned, and everything looks good. So now we can go ahead and face mill our part. We'll just do that real simple. The level is going to be right at 0 on the top of our part. Prof top is 0.025, the top of our stock. This isn't really that important. And then we have a clearance of 0.1, so we can move our tool around above the part safely. Let's just do this by creating a simple line. Actually, I'm going to get a top view, zoom out a little bit. I'm just going to create geometry, and I'm going to create a line. And then here's 0 here, so our cutter is 4 inches in diameter, so we need to go minus, say, we'll go 0.1, so we're sure we're not banging into the part. And then Y, let me see, I'm looking at, I'll watch the readout line right here as I move my mouse there, and it says it's about minus a 1/2 inch. And then in X, might as well get that while I'm here. So it's square, so I'm going to have 5 inches. So we can do our first pass at, let's say, Y minus 1.5, and then it'll default to Z because the level here is at 0. And then we go to the X, so it's 5 plus 2.1. And then the Y stays the same. And now when I press enter, it assumes it stays at 0, Z0. So now we have our first pass. So now let's just zip down here and make another pass across. So the X, I'll click in the X field, and then I'll snap to the end of this line. So we've got our X, our Y now will be minus 5 plus 1.5. So we're coming down to here and then going up 1.5. Z is still at 0. Then the X, I could type it in or I'll just snap it there. And then the Y is minus 3.5. And then we've got our 2 passes that will face this part off. So I'll get an ISO view. I'm going to go to verify. I'm going to toggle my stock on, move this, slow this down, and push play. So it's kind of hard to see here. So I'm going to change the mode here to step. And I'll rewind and play it again. And now the cuts will be colored with the step color. Okay, so we've got it milled off. We've also noticed that the tool went heading off to the north there. If we look at our work setup, we've got our specified home position. This is where it went to X2, Y8, way out of the way, and Z 2 inches up above the part, plenty out of the way. So that's what that was all about. Okay, so yeah, that's kind of in the way. So I'm going to hide this step. It's still there, just kind of out of the view for us. So I'm going to right click, and then I'm going to hide layer step. So now let's go ahead and spot drill the holes. So that'll be with step 40, and then I'm going to do a create from solid hole. I'm going to pick any surface on the solid. We don't want to match the diameter. We want to get all the holes, the big ones and the little ones. We want to do the entire solid, and we want to match the Z-axis coming straight down. If we had this turned off, it would find the holes coming up from the bottom as well. So we should get 12 holes. So we should get 86 here, or 88. So we've got all of our holes. Now the problem here is that they're all to depth. So from solid hole knows the depth of the hole. Well, we don't want that for our spot drill. We want a spot diameter of this countersink. So the spot diameter here is 0.343. So let's start with that. And let's put those 4 holes in the active group. So I'm going to turn my filters on. And then I'm going to use my group arrow. The filters will filter out surfaces. So I'll do that guy, that guy, that guy, and that guy. So now I've got those 4 that I want to be a spot diameter of 0.343. So now I can go to property change, holes and points, and then we'll change the spot diameter to 0.343. And then that should take care of that. And then let's do a new group and we'll get our smaller holes. All the different ways of selecting groups. And then let's go ahead and find out what that diameter should be. Oh, I've got my filters turned on. Turn the filters off, then I can get the element data of that. And that's 0.21. So now I can do the same thing, property change, holes and points, and then change that spot diameter to 0.21. And then that should take care of that. Let's verify that. So verify. And then we come back with the spot drill. I think I would like to see the spot drill a little more optimized. So what I'll do is my step picker, select elements of this step and put the spot drill in the active group. And then I can go to order path optimize. And I'm going to say up at the upper right corner, so I'm going to say 5 by 5 I'm going to pick closest, and I'll hit go. And you can see it's kind of hard to see against the dark background, but let's just verify it. And you can speed this up and slow it down as it's running with your numeric keypad. Yeah, I like that better. Okay. So now let's drill the through holes. Yeah, I'm going to go ahead and hide selected. And now let's go with step, drill is that? Yeah, I think it's step 50. And we'll go back to create from solid hole. Pick a surface, any surface on the solid. And this time we want a match diameter. On this first one, I'll go by example, and then for the cylinder, I'll pick that cylinder. And then notice, even though it's dimmed, it filled in our diameter. And I think that's all we need to do. Just create all, and then that looks like that worked. So now let's go with our other drill, or tap drill, which is that one. And then this time our cylinder will be one of the small ones. And then that updated the diameter. Create all. And then let's change now to our tap. And that should just add 8 more holes. And it does. Now the drills and taps all knew the depth of the holes. So we're good there. We'll take and verify this. And see that, speed it up through that. The spot drill, now slow it down. So it knew the depth of those holes that they were through. It knows the depth of these holes. And then the taps. And then you can see that it knows the difference between the blind holes and the through holes. Okay. So now all we need to do is to machine, profile mill the inside and the outside of this part. So let's do that with our finish mill. And we'll use solid milling profile. Now, if we were in like production milling, we would have to extract a boundary off of this and then use the wireframe milling profile and then do all that messing around. But with the solid milling, all that's unnecessary. And I'm going to use the tangent and adjacent picker. And what I want to do is to take and put all of that in the active group. We want to profile mill all of that. And then we'll go to more. And we'll pick our leads. Yeah, I think that looks okay. We're going to lead out that matches. I'll accept that. But right now, we need to let it know where to start. So let's let it start somewhere up here. So let's go with the single and the point. I'm just going to snap a point somewhere near here. So we'll do it over on the left side. And let's do a through clearance of 0.02. Let's make our depth of cut a little more than a ½ inch, because that 0.02 will give us 2 passes. So let's say 0.75 for the depth of cut. And I think that should do it. And there's that. Well, it didn't put it in the right place. And do that. Start point. Snap there. Okay, so I just snapped to the top of the hole and then I got it close to that side. Well, let's go ahead and verify this. Speed up all the facing and drilling and whatnot. Looks good to me. So basically all we got to do now is do a new group. And again, with our tangent picker, do that and just do the same thing. And it should put the lead out in and out on the back side. And that should complete our machining of this. Profile the inside and then profile the outside. Okay. And then if we can look at our part and we can see that it's all machined all the way around. And going to call that good. So now all we got to do is just go to Create NC Code. The machine is still our 3-axis milling center. I'm going to do an open code file. And then there's our code. This information all came from the job info, so on and so forth. And there you go.